Welcome back everyone, Patrick here, moving on to the next word problem. This one's actually going to be very similar to the previous one that we did. This is a popular type of question, so I wanted to go over another scenario for it. Now, when I'm going through this process, I'm assuming that you've watched the previous example. There's going to be lots of carryover, so hopefully you're watching this on the website and following in order. If you're watching this on YouTube, you can go to the website. The link is in the description box. So we're told a concert currently sells $14 tickets to 165 people, and then we're told for every $2 increase in price, 15 less people will go, and we have to find the ticket price that maximizes revenue. So just in general, as we've mentioned in the previous video, what is the revenue equation? Well, it's basically the quantity or the number of items sold, or the number of products sold, whatever that is. In this case, it is tickets to a concert. And then it's multiplied by the price per item, or the price per ticket in this case, right? The price per product. That's the general formula that applies to any scenario. So currently, what's happening is a concert is selling 165 tickets to 165 people at $14 per ticket. Right? That's the current revenue. And so when you multiply that, what you would end up getting is $2,310. So that right there is the current revenue. Let's actually write this just to keep track of it. So the current revenue is 165 times 14, which gives us 2,310. Now, what they're saying is that the concert now has an option of increasing the ticket price, but every time it increases the ticket price, less people are going to go. They're going to be able to sell less tickets. However, if they can get a higher revenue, then it might be worth it. So what they're saying is that for every $2 increase in price, 15 less people will go. So let's say we increase this by $2 to 16. 15 less people will go. So 165 minus 15 would give us 150. Or if we increase it to $18 per ticket, then 15 less people from here would go. So that would end up being 135, etc., etc. So that pattern is going to continue. And so what we want to try to figure out is there some kind of combination here that's going to maximize this revenue? And like we did in the previous example, what we're going to do is we're actually going to create an equation here. So we're going to let's introduce some variables here. So we'll let R equal the revenue. And then X is going to equal the number of $2 increases in ticket price. Okay, we're going to let X equal the number of $2 increases in ticket price. And so what we can do now is we can generalize this revenue formula a little bit more with this new variable. So what we can say is the price per ticket is going to be 14 plus 2 times the number of these $2 increases, X, like that. So that's going to be the ticket price right there. So currently, X is 0, right? If we don't increase, then the ticket price is just going to be 14, the current ticket price. But let's say we increase it. We have a $2 increase, right? This X here represents the number of $2 increases. So if X is 1, we'd plug it in here. The new ticket price would be 14 plus 2 times 1, which would give us 16. Or if X is 2, we would have two $2 increases. So we plug in 2 here. 2 times 2 is 4. 14 plus 4 would give us 18, etc., etc. Now, we know that for every $2 increase in price, 15 less people will go. So the number, or the quantity bracket here, we can say is 165, the current level, minus 15 times x, like that, right? Because if we increase the price by $2 once, x is 1, well, if we plug in 1 over here, 15 less people will go. 15 times 1 is 15, 165 minus 15 will give us 150. Or if we increase the ticket price 2 times, so we have two $2 increases, again, an x value of 2 would go here, we'd get 18 in this bracket, and then an x value of 2 would go over here, and we'd get 165 minus 30, which would give us that 135 bracket that we had before. Right? So this, and then we're letting the revenue be R. And so now notice that we have an equation for the revenue, and notice this is actually a quadratic equation. It's already factored for us, and so from here we can find out at what x value is the revenue going to be maximized. So the way we can find that out is we can first find the intercepts because it's already factored for us. So let's find the points at which the revenue is going to equal 0. And then once we find those points, those x values where the revenue is 0, that's going to be the intercepts on the graph. And then we can find the midpoint between the intercepts to get the axis of symmetry, and that's going to be the x value of the vertex of that maximum point. Right, so I'm just going to do the algebra first, and then I'll draw the graph at the end and explain how all of it works. So here, to find out what x value makes the revenue equal to 0, we got to find out when is each bracket going to equal 0. Because if one of these brackets is 0, then the whole thing is going to be 0. So there's actually going to be two x values here. So over here, we'll have 165 equals 15x. If we bring this over, divide by 15, divide by 15. And so we'd end up with an x value of 11 over here. Right? So at an x value of 11, the revenue would be 0. And that makes sense because notice if we plug in 11 into these brackets, here we would have 2 times 11, which is 22, and then 22 plus 14 would give us 36. So the ticket price would be 36, but notice when we plug in 11 over here, we'll have 15 times 11, which is 165. 165 minus 165 would be 0. Right? So even though the ticket price is $36, there's going to be 0 people that go to that concert. It's going to be too high of a price. So an x value of 11 is one option that would make the revenue 0 because no people will go. The other option is if the x value is -7. So that would mean instead of increasing the price by a certain amount, by certain $2 increments, we would decrease the price by $2 increments. And in this case, if we plug in -7 here, 2 times -7 would be -14. 14 minus 14 would be 0. So at this x value of -7, instead of the quantity of people or the quantity of tickets being 0 like it was here, now the ticket price is going to be 0, which would make the revenue equal to 0. Right? So both of these x values, they represent different scenarios, and we went over those scenarios in the previous video in a little bit more detail as well. But hopefully at this point you're comfortable understanding what both of these mean over here. So those are the x-intercepts. So let's actually keep track of these here. So the x-intercepts are 11 and -7. Or if you want them in coordinate form, 11 and 0 and -7 and 0, right? At an x value of 11, the revenue is 0. At an x value of -7, the revenue is also 0. And because we have the intercepts, now what we can do is we can find out what the axis of symmetry is going to be, or the x value of the vertex. And so what we can do is we can add both of them up, 11 plus -7 divided by 2, which would be 11 minus 7 divided by 2, which would be 4 over 2, which would give us 2. So the x value of the vertex would be 2. So at that x value, we're going to get a maximum revenue. And you could tell it's a maximum, even though there's no a value in front here in this format. If you were to expand all of this and put it in standard form, notice that the leading coefficient would be negative 30x squared, right? When you multiply this negative 15x times this 2x, you'd end up getting negative 30x squared as that leading coefficient in standard form. And so notice that the a value would be negative, so we know it's going to be a parabola that opens down. So any vertex that we get on that is going to be a maximum point, right? Because sometimes if the parabola opens up, then we'd get a minimum point, right? This would be the x value of a vertex, that would be a minimum. But in this case, it's a parabola that's going to be opening down. If you take this graph and if you plug it into Desmos, you'll see that it's a graph that opens down. And so the vertex is going to be a maximum. And now that we have that x value of 2, what we can do is we can take that x value of 2 and we could plug it into the revenue formula to find out what's that maximum revenue. And so what we would end up with is 165 minus 15 times 2, and then we'll have 14 plus 2 times 2. All right, so we're increasing the price by $4, right? Notice here, this would end up being 14 plus 4, which would give us 18. And actually, that's the answer to this question. I'm going to go into a little bit more detail explaining everything, but this is actually all you need. That's the ticket price that maximizes the revenue. But let's go through the entire thing. So we'll have 165 over here minus 30, and then we would end up with 135, like that. So if you multiply these, if you actually want the maximum revenue, 135 times 18 would give you 2,430, like that. So that's the maximum revenue. So just to, let's keep track here. So the max revenue, when is that happening? Well, it's happening at a ticket price of $18, which is the answer to the question. But sometimes they'll ask you different things. I mentioned this in the previous video as well. Sometimes they'll ask you, what's the number of tickets sold that will maximize revenue? And so in that case, the answer would be 135. Or maybe they'll ask you, what is the maximum revenue? Well, in that case, it's going to be that 2,430. So you got to read the questions very carefully with what they're asking for. All right, but in this particular case, the answer is actually 18. And just to quickly show you how all of this looks on a graph, just to really drive the point home and make you understand what's happening, the two intercepts we found were -7, which is like over here, and then 11, let's say it's like over here. The axis of symmetry is happening at an x value of 2, and then we'd have a maximum point there. So 2 and then 2,430, like that, right? And so if we join these, we'd end up getting a parabola that looks like that. Not necessarily to scale or the nicest looking parabola, but that's how it looks like. And then this point over here, that represents the R-intercept, and I went over this in the previous video. This happens at an x value of 0, and that's actually the current revenue, which is 2,310. And notice that that makes sense. This point, the y value of this point, 2,310, is less than the y value of this point, which is 2,430. Right, so that's how this graph looks. So this here ends up being x, this here ends up being r, like that. And you got to be careful. Remember, x is not the actual price. X is the number of $2 increases in the ticket price. So you got to be careful to not give your final answer as an x value of 2. You got to take that x value of 2 and plug it into that price bracket to get that ticket price that maximizes revenue. And then over here, as I mentioned before, these are the points, these two x values where the revenue would be 0. Here, the ticket price would equal 0. Right? This bracket would be 0, which would make the whole revenue 0. And over here, the number of tickets, or the quantity sold, would equal 0. This bracket would be 0, which would make the whole revenue 0. So those are those two scenarios right there. All right, so hopefully you understand how these revenue questions work. We went over 2 of them at this point. And it's a very popular type of question. You're definitely going to be running into this, and we're going to be doing more and more of these kinds of questions as the course goes on. But the answer to this particular question, even with all of this that I did, the ticket price that maximizes revenue is $18.